We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRE helps formalize industry codes and standards. ISHRE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRE organizes exhibitions, conferences, panel discussions and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrex India, to showcase the cutting-edge technology, innovation and provide a platform for closer interactions amongst the decision makers in the industry. The Acrex exhibition is now growing from HVAC&R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A-Quest, a prestigious quiz competition organized by ISHRE to catalyze the transformation of the budding engineering professionals. ISHRE provides a platform to potential employers to select student members for careers in HVAC&R industry at the ISHRE Job Junction. Young minds are made aware of the need for saving power, clean air and sustainability. The K-12 initiative of ISHRE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVAC&R and building services industry with just a few clicks. ISHRE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection and energy efficiency and conservation, to enter and explore the universe of the Indian HVAC&R industry. Log on to ishray.in that unfolds a panorama of information. Let us engineer a sustainable future together through Ishray.
Can you hear me, sir?
Yes, I can hear.
Sir, welcome, sir. Good evening
Thank
to
you.
all. I welcome to Mr. Monoj Chakravorti. He is mechanical engineering from Bengal Engineering College and specialization in air conditioning and refrigeration, having diploma in management. He has 35 years experience in the field of air conditioning, ventilation, refrigeration, and building automation management system. He handled number of projects like air conditioning and contamination control of missile launching pad at Balasur, air conditioning and ventilation of currency printing press at Salboni and Mysore, air conditioning and ventilation of steel plant and rolling mills, air conditioning and ventilation of multi-specialty hospital at Siliguri. Now he is member of SRA, member of IPA, member of CMA, and presently President Emirates SRA Calcutta chapter and member of Vision Acrex Committee. Welcome, sir, for joining us.
Thank you. Good evening. Can you hear me?
Yes, sir. Yes, sir.
Good evening, everybody. I'm Monoj Chakravorti. I'm from Ishray, Kolkata chapter, and I'm a presidential member also. So you can now start the slides one after another. Today, basically, we will talk about the fundamentals of HVAC and the basics of the systems available, with starting from room air conditioner to central plants, what type of machineries, what type of systems are available, all we will start covering up, and we will discuss, and definitely after the session we will expect certain questions, and I will try to answer those questions. And if we cannot complete within the time span, I would rather request if any question is left out, it may be forwarded to me. In turn, I will forward. So now let us start. Sir, basically, we will have to understand what is our primary goals for HVAC, means heating, ventilating, air conditioning, uh, and refrigeration, of course, are. So our basic goal of HVAC is to provide the desired environment and the add value. Desired environment means this desired environment depends from person to person, requirement to requirement, application to applications. So this is changing. One is the comfort. When we need comfort, our desired environment is some X. When we go to a process, means when we go for some production, we may be requiring our environment desired is Y. If we go to a healthcare operation theater, we may be requiring certain other environmental conditions. So these environmental conditions are not fixed, it changes from requirement to requirement. That HVAC systems will provide the desired environment condition as per requirement. Then next is supporting the process such as operation. Operation means operation theater, and again the operation means operation of computer and softwares or electronic devices. Then promoting a germ-free environment for pharma, healthcare. Then increasing the sales means hotels, shopping malls, and entertainment center. Means how, if we can create a good environment in the shopping mall or any entertainment center, we can expect more footfalls or more people to come there, and thereby our objectives will be fulfilled. Then increasing the net rental income, banks and offices, that is also discussed. Then increasing the sellability of the property means, supposing if we provide with the property with all sorts of facilities, what is required, obviously the people will come forward to take the property. That is, sellability of the property will become more. And then providing a clean environment for electronic and manufacturing industry as per requirement. Even for manufacturing of chips, we require certain specific environment which is provided by the HVAC system. So this is the primary goal of HVAC. Next. Now, what are the base selection of HVAC systems consideration is, what are the aspects we consider for selection of the HVAC systems? One is the temperature, humidity, and space pressure. Space pressure means air pressure in the space, then filtration, and other things also. Then redundancy. Redundancy means how important is the environment. Supposing if it is a requirement of function, means if it is a functional requirement, that in absence of the environmental condition, in absence of the temperature, some disaster or some problem may come out, then we should have the redundancy, means extra machine. Supposing due to any reason, if one machine undergoes breakdown, immediately another machine can pick up, so that the entire area's environmental condition will be remain unchanged. Then, and the next comes to space consideration, because we will select the system depending on the availability of the space. Suppose if we select a system where adequate space is not there, so where we will install the machine. So before we select the system, we should see the availability of the space for the installation of the machines. Then comes to first cost. How much money because everybody has got the planning or spending limitation. So system has to be selected based on that spending limitation, means spending money. That is the first cost. Then the system has to run, means operating cost also has to look into for selection of the system. System selection should not be such that operating cost will go high and recurring expenses will be very large. So that part also has to be looked into. Then how reliability of the system? That means the system which will be selected, how reliable it is, so that the system operation can be assured, and we can also entrust with the equipments. Yes, with this equipment we can maintain the condition. With this equipment we can maintain the tolerance. Then flexibility. Supposing if some changes within the premises is required, how much flexible is the system that it can take care. Flexibility is nothing unusual. Anytime some changes may call for. So system should be such that it can take care the minimum changes. It should be flexible. More flexible is the system, more is the better for the client and as well as for the owner also. Then life cycle analysis, then single ownership and of multiple tenant, means supposing it may be a one owner, the premises is owned by one person, then the system selection will be one. And if in that one premises or one building has got number of tenant, then we may have to select the systems in such a way that every tenant, or if they have a different requirement, that also can be taken care from these systems. If they need the separate billing system, that also can be incorporated in the HVAC systems. Somebody's requirement may be different from somebody. So this change of environmental conditions requirement, that can be served from the selected systems. So these are the basic consideration while we go for selection of the systems. Next is the relative importance of the above factors, where what I've already told above factors differs with the different customers. Now, there are while we design or while we select a system, we will have to first discuss with the requirement. Where from we get the requirement? We get the requirement from the user or from customer or from the clients. Now, while getting the inputs, one of the inputs also we need to know, one is their requirement and what is their maximum capacity of spending. That means what is the first cost they can afford. So we will try to select the system as per their affordability, number one. Number two, what should be the operating cost? Operating cost means energy cost and other things, other means consumables and all. And while selecting this operating cost, because that is the recurring expenses, these recurring expenses, not only recurring expenses, that also comes in the first cost. Supposing if we select the system where my electrical power consumption goes very high, that means I will have to go for a higher size of transformer, I will have to go for a higher size of switch gear, and I will also have to deposit more money to the agency where from I will be applying for the power. So that also comes under first cost of the electrical items. So it is not only the operating cost, but first cost of the electrical items also depends on the system selection. Now, the classification of what are the various classifications of air conditioning systems: standalone systems, decentralized systems, and central systems. Next, standalone system. It is self-contained, factory-made. Individual room control, no cross-contamination, quick installation, low initial cost, no standby is required. That is basically the room air conditioners, what we earlier used to use it widely. But again, it has got certain limitations. One of the limitations, and let me explain what is the benefits. It is no standby is required, simple on-off control, and large temperature swing means I can have 18 and I can set 18 and again I can set on 27. And then but there is no humidity control because standard coil size and coil depth, everything is standard. So it cannot control the humidity. So low, and then comes to cleanliness, air cleanliness. That means level of filtration. It is not possible to have a high level of filtration, low level of air filtration. Then self-sufficient, not dependent on any others, means no operator is required, anybody can operate and anybody can run it. Requires but it requires the exterior wall to fix it because because condenser heat is rejected, it can be rejected outside. If it is rejected within the building, then there will be some heat pocket, hot pocket and heat generation. And air circulation will be in that case hot, and hot air circulation also reduce the efficiency and sometimes it can trip the machine. So we need an exterior wall where the condenser portion comes out. That you people, everybody must have seen. Next. This is just an installation pictorial, what, where and how normally it is installed. And say if we have 5 rooms, for 5 rooms, individual operation is also feasible. So, and if we have got the external wall facade, we can have separate machines for each of the rooms. Next. Next. But it has got certain limitations. It requires a outdoor air for condenser because air-cooled condensers, it cannot be used for interior of the rooms. Supposing a room which doesn't have any external facade, we cannot use it. In that case, it will not get air for cooling the condenser. Condenser for because these are all air-cooled condensers. Then humidification, air filtration, not suitable for critical application because where humidity control is required, where filtration level has to be achieved, there this cannot be used because it is not rather suitable for those applications. Then another is the problem of disposal of the condensate. You can find sometimes some high-rise building in top floor, one machine is installed and some polythene pipes or something is put, where from you will find the drip, drop of water that is falling. So that is falling and sometimes it creates problem for the others. So the disposal of condensate is a problem, as because the compressor and the evaporator and the fan all are inside. Condenser is also inside in the same machine. So there is always a noise. So that noise, if you want a very calm environment in the room, that is 100% not feasible for these machines. So noise is a problem for this machine. We should not expect that this machine will give a very calm and quiet operation. Next. The decentralized systems, that means here we are just separating the systems in two parts. One part we are making it condensing units, means condenser and compressor, we are making one part. Another part we are making the evaporative unit, means coil and fan part and filter, we are making in a separate. And these two parts are joined by refrigerant piping. That is what is normally we can see is a very common thing for the split air conditioner. I think every one of us have seen the condensing unit normally is put outside the room, and the evaporative unit is normally put inside the room against the wall. The cooling unit means indoor units, that is comprises of the cooling coil and the fan, that is low side, and is separated from the condensing unit, that means compressor, condenser, uh, uh, compressor and condenser. They are separated and they are connected together by the refrigerant piping. And best place where there are no external facade. Supposing if there is no external facade available in the room, we can put the condensing unit where the external facade is available, and we can bring the refrigerant and connect with the cooling units, which is placed in the room where no external facade is also available. No external facade is available. So here the problem of external facade is not there. Next. Normally, in each of the places in a multi-story building, you will find the ledges are made, and in these ledges, the condensing units are kept, and then current pipes is taken and connected in the indoor units, and two sets of refrigerant pipes. One is your liquid line, another is the gas line, which comes back to the system again. And even the drain piping also can be planned nicely, because if the room has got any toilets or anything attached, the drain piping can be taken and it can be terminated in the toilet drain, or even it can be connected, common drain can be connected, and this total drain can be taken and terminated in kitchen or toilets or any of the shaft, it can be taken. And if the length of these refrigerant pipes, sometimes this condensate pipe is more, then one can have small condensate pumps also online, which are available nowadays. The very small size, half inch, 1 inch, or 3/4 inch. These type of pumps are available, and even if one cannot provide the slopes, that pump can take care of flow of the condensates. One outdoor unit can serve multiple indoor units. Outdoor units can serve multiple indoor units now, but it is normally in case of VRV system, we know that is possible. We keep the outdoor units, and from the one outdoor units, number of indoor units. That is also a decentralized, but that is VRV units, the variable refrigerant flow or variable refrigerant volume system that I will talk afterwards. But earlier we have, now normally that type of systems is not available much. That means if we have got one number of 3-ton outdoor units, and that 3-ton outdoor units can connect with two number of 1.5-ton indoor units. That was possible earlier. Split units are various models, and they can be, it can be, of course, there is another split type of units where requirements are more, or that is for any auditorium, even for not only auditorium, for a community hall and all these places where requirement is more, we can have ductable split units. That means we can have the outdoor units, and from the outdoor units we can have a dedicated indoor units which is higher in size and capacity wise also higher, and then the dehumidified air delivered by the indoor units is again planned to distribute on the rooms in such a way through a ducting network, and finally to match with the false ceiling or to match with the entire interior layout, it can be done. And in that case, fresh air also can be taken easily, because this fresh air can be taken and it can be connected to the indoor units, and through which the duct will go, and the return air also comes. This return air mixes with the fresh air, and it is circulated through the ducting system. That means the requirement of fresh air is also taken care for such a say community hall or any functions or any fine dining or big dining areas, restaurants also sometimes we use. So single split, there we will have to go for a separate treated fresh air unit, but for this type of thing, we need not think for that. We can take the required fresh air, maybe load will slightly go high, and for which if required, we can have the treated fresh air and connect with the main units, and so that it can circulate. The surface of noise separation as because the two units, the condensing units and evaporative units are separated. These cooling units are inside where compressor is not there. Moderately, much less noise will be generated, because the noise generating part, that condenser, fans and compressor, that is located outside. So moderately and comparatively, your indoor part will remain much calm and quiet. Next. There's another systems that is called package unit systems. Every one of you must be knowing, a lot of people must be knowing who are attending that package units. Package units are normally, earlier it was only floor mounted available, but nowadays water cooled package units with ceiling suspended type or air cooled package units, ceiling suspended types are also available. But package units, earlier we used to have the floor mounted type package units, but in these package units where the entire things are coming under one shell, means your cooling coil, fan, compressor, and if it is water cooled condenser, then the condenser also comes in the same shell. If it is air cooled condenser, then condenser is taken out of the shell, and it is condenser is connected with the compressors and cooling coils and all these things, which is sitting on or suspended in the room where it will be cooling. So these package units is normally slightly larger side, but you can say what is the difference between the package units and the earlier ductable splits. Normally, ductable splits, what we are getting now, it is mostly air cooled. All the ductable units, which what we are getting mostly air cooled. Package units are very much on the water cooled available, and one of the very innovative things, I will not tell, it has started, but not very, not from the long time back of late, that package units water cooled type with ceiling suspended, even capacity comes from 1.5 ton, it can go up to 17.5 or 22 tons. Single units, and but it is water cooled, means if of course the if you have got a system, big shopping mall, say, which is not very high-end shopping mall, but it has got various number of shops, even to the extent of 200 square feet, 300 square feet, 400 square feet area. And if you want to segregate those things, you can put the units in the each of the shop, 1.5 ton or 2.2 tons or like this. And you can have a common cooling tower sitting at the top and condenser water pump sets, and pipeline will run through the corridor, and each of the your shops, that condenser water in and out will be connected. It will be regulated through the valves. That means if my condenser, for condenser cooling, if 5 GPM water is required, I will put the balancing valve and I will just set it 5. That way it can be done. That is also available. That is a very good thing has come up now, because if it is a air cooled, then obviously it will consume more power. But if it is water cooled, at least it will consume less power. So it is, but it is again a factory package. It requires a floor space in case it is floor mounted, and it can be located top also, and better ceiling height is possible if it is floor mounted. That means it will take some floor space, that is fine. But again, it can take a lot of, one can have lot of ceiling height, because you may not have to take the big duct. You may have to say package units capacities are not very high, so your duct sizes will not be more, so you can reduce the duct height. Since the compressor is within the package units, the maintenance is from the outside of the occupied space. Now, question is, sometimes in some occupied space, entry of the maintenance staff is not allowed. In such cases, it is not possible to keep in that occupied space, because if someone has to attend the compressor, if someone has to attend the fan, he will have to come inside. So, depending on the protocol, one has to select where it has to be installed. Now, split and package units advantage is in multiple, it can provide in multiple, that means redundancy will be also can be made, but less size, lower inrush current because units are small, multiple tenant application, because if number of tenant is more, so for each of the tenant you can have one unit. Energy can be metered and saved. That means entered with the tenant billing systems and elaborate tenant billing systems and all these things is not required. Then fast and low cost installation, because first cost is less and cost of installation is also less. And another benefit, if you can go with what the system, what I have told, the water cooled small package units for shopping mall and all, you can reduce the CAM charges. CAM means common area maintenance charges, because everybody is bothered about the CAM charges. Supposing if I can take out the compressor and condenser from the condenser, leave condenser, if I can take out the condenser, then automatically my common area maintenance charges will be more. There is no chill water circulation, because only we are using common what, that means cooling tower fans and condenser water pump sets. That is the only thing what we are using. So that part will become the common area maintenance for the air conditioning system. But it has got again some limitation, that installed capacity is normally higher than the actual load, because if we see when we calculate the load, we consider all the worst conditions. Here, you cannot apply any diversity. Say, that type of worst situation can occur maybe 1 or 2% time of the year, as far as 1% time of the year. But most of the time it will be operating part load. But in the package AC or split AC, no part load operation is feasible. The fresh air and ventilation air quality and its filtration quality is another question mark for the small split AC. There is a problem for the fresh air. That means we will have to go for the separate fresh air unit. But for the ductable split unit, fresh air is not at all a problem. But again, the filtration is a problem. If we want to have a higher filtration in area or contamination free area, that means if the level of filtration is more, then we require a good fan, means a fan with higher static pressure. Normal indoor units cannot serve. Then we may have to go for a tailor-made units. That means outdoor unit I will be taking, and indoor units I can make a tailor-made in terms of fan pressure. Next. Package units have set performance, and parameters such as sensible heat ratios and all these things are fixed. Then fixed size of condenser coil and fan, and fixed rating of air quantity, then tonnage of refrigeration, those are all fixed. That means what I told you, no part load operation will be possible here. Whatever is output, that output will remain like that. Next. Next, we have got the central system. Central system, just, no, you take out the earlier one, after package units. Yes. Next slide, next slide. Next slide. Yes. Next, come to central system. Some of the features of the central air conditioning systems, it can be provide tailor-made solution. Supposing if I have the requirement of 235 ton, I can select my equipments and system to cater that requirement. But for split and package, it is a standard module available in the market. One has to go with that. But for central system, it can be tailor-made. is able to fulfill any or all the design parameters like temperature, humidity, space pressure, fresh air, filtration level. Supposing requirement of temperature with the tolerance, whatever is required, that can be achieved through central system. As far as the humidity is concerned, control of humidity is also very much possible with the central air conditioning system. Filtration is also possible, and air pressure, I can change it as per my requirement. So this fresh air requirement also can be changed and it can be controlled. Next is, as what I have already told, our 100% load is not possible all the time. Most of the time it is operating at 70% or 75% load, or even 50% load, sometimes 40% load. So depending on the usage pattern, we normally select the diversity. And this diversity is very much possible. The diversity factors is very much possible to achieve when we go for central air conditioning system. By applying diversity, we select the condensing part, means compressor, the main unit, chiller, we select based on the diversity. But as far as the total load is concerned, that is taken care in the inside space. Inside space, whatever load is there, we select the air handling units or fan coil units or cassettes units, all in line with the requirement. There is a logic for that, because supposing we have 2-3 rooms. In all the rooms, the load is not equal for all the time. In one room, my load is less. So, other room load may be 100%. So, if I apply diversity on the indoor units also, then wherever 100% load will be there, I will be starving with the requirement. I cannot fulfill the requirement. So, inside of the premises, we normally don't apply the diversity. But major thing which normally comes for the power and capital cost also, that is the chiller part, that we normally apply diversity, and thereby we can also, where it is a functional based air conditioning, we can also have a possibility, not only possibility, we normally take the redundancy also based on that diversity. So first cost is generally here one thing. First cost is generally more for this system, because here we made the things tailor-made, and then lot of controls are incorporated. And for that, we normally able to achieve the requirements of clients and customers. Next. Next. A central system can provide a standby need. This I have already covered. A space requirement is more. Additional space is required for piping, ducts. Secondary services also cost more. And this I'm telling you, space requirement is more, means sometimes we will have to have a when we are going for the large system, and if we compare the system with split and versus central, or package versus central, definitely package will fetch less area compared to the central system, because central system has got a separate plant room. That plant room has to be taken adequate size considering the redundancy as well as considering the operation and future maintenance and cleaning and all these things. So, but if we take a package AC as because the capacities are low, it is sizes are also low, and we can have the less space. But central plant, if we have with the air handling units, then the air handling units also will be requiring a separate space on the floor. Each of the premises inside, we require separate. And now we need some space for routing the pipes from which is the pipe coming from the plant room and connecting it to the indoor air handling units or fan coil units, whatever is there. And they say if in case of air handling units, we are to take the ducting, and that ducting sometimes becomes large. For this, we require large areas too. But these routing of the pipes we normally take from the shafts, and these shafts are located normally from the floor to floor. That is, shafts are taken, and precautions also has to take so that through the shaft, under any circumstances, no fire or fumes can escape. So the annular space between the pipes has to be sealed by means of fire retardant material. And noise level can be regulated to the noise level can be regulated to the desired level by using the acoustic lining and acoustic treatment. Next. Now, there are various types of central air conditioning system: all air systems, all water systems, and air water systems. This defined by the medium that enters the uh, air conditioned space for maintaining the inside design conditions. These three types systems are available. Next. Now, when we are taking all air systems, the base system for critical application for low tolerance level of temperature, humidity, and pressure level, high degree of filtration, high level of cleanliness, and low noise level. Here, basically, what we find that air handling units is from the supply air is supplied from the duct, it is coming, and then through diffusers and all it is supplied, and then this is going back to the air AHU. This air is going back to the AHU. That means your supply media, that is cold media, is air, and hot media is also air. From the air is entering in the premises, that is air, and air going out of the media going out of the premises is also air. So that is the basic thing, that is all air system. Here we have the better control, and remotely located air handling units means, supposing if the air handling units is located at one part and say 30 feet or 40 feet away, we can have the duct routed through that, and then as per requirement, we can select and we can circulate the ducting. Through that, and return air path also we can take as per requirement, and we can have also the system, we can have air throw from the bottom and take the air back from the top. And that is most energy efficient system, but that also sometimes has got some limitation, means less flexible. At a later date, if we want to change the layout of the room, that may create problem. Then its application is basically the comfort application, all healthcare application, and electronic and clean room application, and the critical applications wherever it is required, there it is all air systems are taken. Next. All water systems. All water systems means we are generating chilled water, and that chilled water we are sending it to a unit which is located in the premises which we want to cool. That is the say fan coil units. There we are sending the chilled water. That means in the premises we are pushing the cold water, and from the premises we are taking out of hot water and sending it back to the chiller plant. There, both the things are basically water. Water coming in, water is again going out of the premises, which we are considering as condition. All water systems are very much useful. Individual room application, hotel rooms you will find with the fan coil units. Then individual controls are there, independent controls. Supposing I may not feel like operating the AC, I can switch on the FCUs. Then isolation is also required. Isolation and no cross-contamination, because this air which is coming in the room, that is not going other room. So there is no cross-contamination. But again, question is no humidity control basically for the comfort application. Higher noise level because we have the fans in the fan coil units. Then filtration is also another problem. Means not a very high level of filtration is possible. It is lower level of filtration because one stage filtration, and then fresh air. If we have to put fresh air, we have to take a separate fresh air system and we will have to connect it. Separate fresh air means it is not just hot air we take and connect it. We will have to take a treated fresh air system. Low level of filtration that I have already covered. So this is mostly you will find it is applicable in your hotel for the comfort applications. Next. Now AC system equipment system. The main components of the AC system. One is the chilling machine. Heat in the chilling machine, what is there? Heat rejection. That means condenser, heat exchanger. Either it is air cooled or water cooled. Compressor, it may be centrifugal, it may be screw, it may be scroll, and it may be reciprocating also. Starter of the machine, it can be variable speed, it can be fixed speed starter. Then chilled water pumping system. Now chilled water pumping system, it may be fixed speed, it may be variable speed, it may be primary fixed speed and secondary variable speed. Then comes air handling units. The AHU is not, it can be floor mounted, it can be ceiling suspended. Filtration, it can have pre-filter, fine filter, HEPA filter or ULPA filter, all in combination. It can have heat recovery units and humidity control units. And in addition to these, another components are also there for this AC is the cooling tower. For the water cooled system, that is where condenser is water cooled, their cooling tower is also used. And another thing is also used, that is condenser water circulation pump. That means the water what we use for cooling of the condenser, that water we do not reject. We take it back to cooling tower and circulate it again. So pump sets is required, that is condenser water pump sets. Next. Next slides.
Done, sir.
Next. Typical feature of the, I'm just giving an example that is the typical feature for the hospital application vis-a-vis a commercial building AC application. Operation is 24/7, 365 days. Just next 25 days and high operating cost. Hence, equipment as well as the system efficiencies are very much important. Minimum downtime, hence requires high redundancy. Various area requires different degrees of cleanliness, fresh air and humidity controls are also required, and hence one solution that fit for all is not possible. Next. How does it work in an actual installation? The thermal energy moves. Next. This diagram shows the cycles, how it operates. From one is condenser cycle, another is compressor, thus condenser to compressors, and then compressors to through chilled water pump to the cooling coil of the AHU, and from the AHU cooling coil, it is again coming back to compressor. This is shown, and from the AHU, basically, water enters at low temperature, and the air picks up the cold, and air became the colder, and water picks up the heat from the air, it becomes warmer, and it comes back to the cooling coil. So this is basically the cycle, how the central plant, how it works and operates. Next. And chilled water system, cooling coil is there, cooling tower, chiller, and pumps. It is shown. These are the most important. Pumps means depending on the type of the system, if it is a water cooled system, and then two sets of pumps. One is chiller pump, chilled water pumps, another is the condenser water pumps. In case of air cooled systems, one set of pumps will be adequate. Next. Now, in a system, basically the most critical thing is the power consumptions. How, for a central plant, who takes the major power? That has to be looked into. In a building where central plant is there, normally around 55 to 60% of the energy is consumed by the air conditioning system. So selection of the system equipment is very, very important. If more or less some approximate idea I can give, for any central plant, chilling plant, basically the chiller takes around 60% of the power. Chiller means compressor. Mainly the major part is the compressor in the chiller that takes the 60% of the power. Then chilled water pump sets takes around 15%. Then condenser water pump sets takes around 6%. Cooling tower also takes around 6%. And around 30% taken by the air handling units. So we will have to take maximum protection basically for selection of the chiller because it consumes 60% of the total system power. And that again, we will have to look into the requirement and application. It is for which application. Next. That is basically an example if redundancy, how much we should take, and it gives a idea also. And there we are. It is not mandatory that although it is written that in this application, screw chiller is a better choice. That is not a. It is just a suggestion. Means it's a balance between the cost and the power. Supposing if this 24/7 application into 365 days, 24/7, if the application comes for a, it normally comes into hotels. It comes sometimes in hospital also. Sometimes in the big hotels, they prefer even to use the oil-free chillers because in the oil-free chillers it gives less power consumption, but the first cost it is very much higher, and the return on investment, if they calculate the return on investment, if it is within 36 months, then sometimes clients goes with the oil-free chillers. There are a lot of installations. There we have seen the oil-free. We have done some installations, lot of installation with the oil-free chillers, where although we first gave the basis that our total return on investment will be around say 36 months. But finally, we have recorded the return on investment on 26, 27 months. And we got a very good result. And this is done in one of the corporate office where it is not 24/7, 365 days. There we got it 28%, but 28 months is the RY. 250 tons, we have taken three numbers of, not 250 tons, 300 tons, we have taken two numbers of oil-free chillers. And of course, we have taken one number of small chillers. But oil-free chillers is a fantastic result we got with the multiple compressors. Then in another place also we got, that is 24/7 application, and that is one research center, and that is in Kolani, genomics research center, where normally the microbiologists, they do the researching with the viruses and all bacteria. There it is for 24 hours. There we got 22 months, 215 ton oil-free chillers, three numbers is working. So that depends, that is also, of course, a Government of India projects. And both are, one is Government of India, another is Government of India, that Coal India, that is also Government of India. But and another place in a hospital application, there we have worked with there we have worked with the screw chillers, 23 XRV carrier. That is also a fantastic machine we have used, where your capital cost was very high initially. At that time, oil-free was not in use, but 23 XRV was there. And we got the return on investment, whatever normal screw chiller and 23 XRV, we got the return on investment 16 months only. That is in a hospital at Siliguri. So we are to look balance first thing, but we are to nowadays we are to look very much on the energy, and accordingly we should select the equipments. And equipment selection we had to do with say minimum efficiency criteria. IPLB needs to exceed the ST standard 90.1 and the ECBC guidelines. In ECBC guidelines, there are three things. One is ECBC, ECBC plus, and super ECBC. We can, depending on the balance with the first cost and the energy cost put together, if possible, we should aim at going to super ECBC. That is the prime idea, and we should definitely look into few things now in the light of that COVID. Another is very important criteria has come up with the filtration level and the humidity level. Although it is specified, but mainly for the healthcare part, humidity is the most important criteria which has to be controlled. And necessary controls has to be incorporated there. And next, then chilled water pumping system. Chilled water pumping system means we can also save the. I talked about the chiller power saving, but around 15% of chilled water energy is taken by chilled water pumps. There also we can save a lot by using the variable pumping system. And variable pumping system, if we go for the primary variable pumping system, we will have to be very careful in selection of chillers so that minimum flow has to be maintained. Otherwise, there may be some problem of accident. And we can go with the primary variable flow system, but at least we should aim at we should go that fixed primary primary pumps and variable secondary pumping system, which is very common, and that also saves a lot of power, because depending on the load of the user point, and it starts pumping the chilled water balance, it bypassed and taken back with the return chilled water line, and it goes to the goes back to the chiller, to the primary pump. But and your return chilled water temperature also comes down when the part load operation is there, and the delta T will, in that case, will be definitely coming less for the this one HU side. And here chiller will be operating in a part load condition, and part load condition, if chiller operates, then we will have to take we can take the variable speed chiller, because the variable speed driven chiller, if it cannot operate in the part load condition, then it is useless. We should take variable speed chiller where the part load operation is predominant. So those things we will have to take care, and pumping also accordingly we will have to take the variable flow pumping system. Even but one thing, pumping system has to be variable. We will have to take the controls very carefully, and we will have to see the controls are functioning. Supposing we have taken variable secondary flow pumping, but in actual practice, if the say sensors are not operating, pressure sensors are not operating, or the temperature sensor, whatever has been put, is not operating, then and there is no use of taking the variable flow pumping. Because I have seen from my own experience in one of the very renowned shopping mall in Calcutta, and one of the best shopping mall in Calcutta, there all variable flow pumping systems are there. But once we went for checking, and we find the operator, they have bypassed the all sensors and made the BFD running at a constant speed. BFD pumps, that pumps running at a constant speed. Then when we asked them, they told, no, we know this operates at around 70% or 80%. We have fixed up the speed on that and it is operating like that. So if that is the case, then the entire philosophy is defeated. So we should take care also the operation part. If we want to really select the right units, that operating part also we should take care very correctly. Next. Now, why the humidity control is there and what is the safe band that is shown here, that is as per the HVAC guidelines. So it has been given, and we should, that the thick band, we should aim at operating with our system with that. And that control is a must for humidity, which is better for the human being. Next. This is basically the air handling system, the operation theater, where filtration is used, pre-filter, fine filter, HEPA filter, and the laminar flow at least up to the level of operating table. Beyond that, it will become a linear. It will not be 100% laminar, it will become a linear. But up to the level of OT, means OT table level, it is totally laminar. So and here normally three type of filter is used. One is pre-filter, fine filter, and HEPA filter, and energy recovery wheels are also used, and humidity control required with the reheaters or more different dual wheel, that is enthalpy wheel, that can be different controls are available that can be used. Heating is also one of the control, or another is that dual means dedicated units can be used, dedicated outdoor units, dedicated outdoor air units, that is DOS system, what we used to tell, but it is again where 100% fresh air is required. There we can think of DOS, because DOS is definitely going to be costlier. And another is the type of the AHU. It must be a floor-mounted type and proven for fungations. Fungation, because why floor-mounted type is preferred for the hospital or healthcare application, because it should be easily accessible for maintenance and maintenance purpose, cleaning and maintenance purpose. Otherwise, if the AHUs are, say, ceiling suspended and all, then normally people avoid the maintenance portion. Then the critical care units for the hospital, the CCU here normally pre-filter, fine filter, and supply and return air is both ducted. For OT, normally supply and return air is ducted, and CCU is also, but CCU did not have any HEPA filter. It is direct to HU, that fresh air is directly connected with the HU, and generally not that humidity control is normally within not that critical, which is very much critical for your OT. That much critical it is not there. And it is also preferred to have the floor mounted. In fact, for all the hospital units, it should be floor mounted, because hospital is a very, healthcare is a very sensitive area, and there this maintenance is also has to be carried out. Then other areas of the hospital like wards, IPD, etc. Here is also two-stage filtrations, and supply air is ducted. Return air need not be ducted, but the fresh air is directly in the HU. And sometimes, in my opinion, it should be on the floor mounted, but sometimes it is made ceiling suspended too. But ceiling suspended, it is made mainly the OPD with the logic that OPD is the number of patients, it varies. So if the patient reduces, then what happens? They can reduce one number of, or they can stop one number of AHU, or normally it is ideal if they have the air-handling units with the VAD, so that as per requirement, the fan speed can be changed, and that can be regulated and operated. But again, the question is the fund and the budget. Then admin, back offices, OPD is only pre-filter, and the supply air is ducted, is a one-stage filtration. But now there is no question of one-stage filtration; it is a two-stage filtration is the minimum. And it is directed to the HU and can be sitting or suspended unit or floor mounted unit, or even sometimes if the small cabins or chambers are there in the offices, back offices and all, it is made FCUs, that fan coil units also, because it can have its independent control. And I think that's next.
Okay, sir, complete.
Okay, Anna? Okay, thank you. And I think this is in general, in a nutshell, what is the basic things. Now, any questions?
Sir, I read the questions.
Pardon?
I read the question, sir. Sir, first question is, how will decide to fill the how much kilogram of gas in the AC? For example, how we will decide to fill the how much kilogram of gas in the AC? For example, how much R22 gas to be recharged in the compressor if the capacity of outdoor is 1.5 ton?
How much? Can you
Sir,
repeat the question?
Yes, sir. How we will decide to fill the how much kilogram of gas in the air conditioner? For example, how much R22 gas to be recharged in the compressor if the capacity of outdoor is 1.5 ton?
Actually, how much gas will be, normally these are basically depends on the manufacturer to manufacturer. They have the standards and they tell what is the basics, what is normally charged a quantity and what should be maintained normally. It is very difficult right now. Often I'm to answer, but one thing I'm telling, it is normally told by the manufacturer who supplies the machine, say 1.5 ton split units. They will tell that how much gas will be required, because that comes in their manual also. But anyway, I'm noting down. I will inform you the exact calculating thing. Okay.
Okay, sir.
Ah.
Now, next one is the what is better VRV? What is better VRV system or chiller system?
Yes, it is a valid question. VRB system and the chiller system, definitely, if it is a places for it is again depending on the applications. Say if we go for a healthcare or the critical applications where control of humidity and control of temperature is very much essential, and if its operation is 24/7, and there I feel that we should go for the chiller system because of two things. One is these controls can be taken care by the chiller system very nicely. Number one, number of stages of filtration in the HU can take care. Number three, if we go with the water cooled system, then obviously the power consumption of water cooled system is less than that of air cooled system. We can save a lot of power for that. But for small offices, or even where we can have 500, 600 or 700 square feet areas of the small offices, we can think of VRB system, provided we can have the what is the architectural layouts permits to put the outdoor units on the ledges or on the rooftops. Because if we go with the rooftop outdoor units, that means in a future there is no possibility of further expansion. Number one. Number two, this refrigerant pipelines length also will be increased. Although VRB system can take care that increased length, but it increases. Due to increase of this pipeline length, there is in case of any leakage of the gas from the pipe, it is very difficult to detect. In such cases, in a bigger plant size, when it becomes more than 500 tons or more, or if it is for an application of office or hospital, always I should go for central plant. And for the office, we should go for office or shopping mall also. We can go for a larger plant, we can go for central plant. But for medium size, we can go for VRV also. And for VRV, there are certain applications nowadays it is taking place for VRV, that is VRV units, outdoor units with a tailor-made indoor units. Supposing if we want to use the two-stage filtration or three-stage HEPA filter using, then we require a fan with a high pressure, and that can be tailor-made now. So that also adds to the cost. So in my opinion, for a higher plant, always we should go for central. That is going to save the energy, and that is going for the maintenance. Like say any leakage of water can be found out easily than finding out leakage of gas. Hello? Hello? Next. Next. Next question.
Sir, how we can calculate the energy consumption yearly for different systems?
We can calculate the energy consumption. The first thing is calculating of energy consumption. We can have the energy meter, or we can have the BTU meter, or Even we can have the, from the BMS system, it can directly calculate it. If we have the BMS system, we can have the kilowatt meter, we can install, and from there we can calculate the energy, how much it is consuming. And recording is automatically there. Plus, in the BMS, if we have got the, say, chilled water in and chilled water out temperature, what is the tonnage? And from the rating chart of the chiller against that tonnage, what is the consumption? The compressor is consuming how much? That can be found out. From the pump, if we have got in the kilowatt meter, we can, it is consume how much amps that comes out. From the BMS, it can comes out easily.
Okay, sir. Now next one is the for small TR application are oil-free chillers economical.
For
For small TR application are oil-free chillers economical.
what is small VRF? For a small VRF system. Hello?
Sir,